Welcome to qnawire.
So we need to find the time that it's in the air and then solve initial x velocity. That's when I say the time that it is in the air, I mean the suitcase is in the air, not the airplane. And we need to then multiply that time by the initial x velocity, and we can see how far away from the dog the suitcase lands. So we know that the initial velocity in the y direction would be equal to the initial velocity of the airplane times sine of 23 degrees above horizontal. And we know that here we're going to choose upwards to be positive. Therefore, our change in the position and change in y position would be equal to negative 114 meters. And we can say that our acceleration here would be negative 9.80 meters per second squared. This would be in the y direction. There isn't any acceleration in the x direction. We also know that the initial velocity of the airplane is 90.0 meters per second. So we can say that we use kinematics, delta y equals v initial y times t plus 1/2 a y t squared. And we can say that negative 114 meters is going to be equal to 90.0 meters per second multiplied by sine of 23 degrees times t, and then plus essentially 1/2 times negative 9.80 meters per second squared times t squared. This is essentially a quadratic equation. You can use the quadratic formula. Because it's quite convoluted, though, we can simply use the solve function in your TI-84, 85, or TI-89 in order to solve for t. And after using that solve function, we arrive at t equaling 9.60 seconds. So essentially, to find the delta x, denoting the distance from the final x position of the suitcase to the x position of the dog, we can then say that this is going to be equal to the initial velocity 90.0 meters per second times cosine of 23 degrees, and then multiplied by 9.60 seconds. This would equal essentially 795 meters. So the suitcase is going to land 795 meters away from the dog. That is the end of the solution. Thank you for watching.